Okay, now let us take one of the example from internet to demonstrate how we can use the numerical ODE method to solve the RL circuit. So as this a typical RL circuit that you normally seen before, and then this how you can get the equation for the circuit using the laws that you learn, like Ohm's law. You get the IR equal to BR and so on and so forth. And then using the math analysis, you know that in the only loop that you get the V in equal to IR plus L di dt. After you rearrange, you get this yellow color equation. And then the step one that you learned just now is we get our fsy. In this case, the x will be the t, the independent variable, while the dependent variable, the I, will be the y. So that's why we can get our first order differentiation equation, the di dt, okay, equal to the information that we substitute, that is 5 for V in as according to this given information. The R is 50 ohm and the inductor is 1, so that's why you know C 1 over 1 equal to 1, so that's why it's not here. And no initial current, so that's why you know that what you know that at the time the I when the time equal to 0, the that you will, I think this t is much better, that you t equal to 0, or just write the 0, that the current equal to 0 ampere. So this is the initial information is that we obtain from the equation. Okay, so basically this question actually they try to ask us when we're going to reach the steady state current. So what's the steady state current? I think that you might can remember before, that is the current is steady. Okay, so the objective for this demonstration actually is to trying to get this one, this exact solution that you can observe from the when you solve the equation using the exact method. Okay, and then you can come out this one. So we can estimate that we can choose our hedge. Okay, for this case we choose our hedge equal to 0 0.025. I think will be much better. Okay, our step size, so that we're going to get 1 point at here. Okay, let me take something to show you. Okay, so that means we're going to have 1 point at here. So this 0 0.25, that the value that we estimate should be a minute. Okay, should be how many? It's more than 0 0.06 something, or 0. Okay, should be around there. There our next estimation point will be 0 0.05. So if you approximate to 0 0.09 something, that in between we're going to estimate one more point is at here. Okay, next one more point at here. Okay, and then lastly I think we're going to get the same value. It says that same value after 0 0.1, the time equal to 0 0.1. So this is what we're going to estimate. Okay, so this is our step size. So if you go to the slide that we demonstrate, so we go to step 2. Step 2 is what? Step 2 is tabulate the suitable table. And basically this is the table. Let me copy and paste the framework. Okay, so step 2. Okay, tabulate suitable table. So this is the table that is normally will be used, and then the exact one that we don't have, because we are not going to plan to solve the one, but we just trying to demonstrate how closer that we will get when we're using this the Euler or the Euler. Okay, pronunciation, the right ones be the Euler methods for ODE. So as I mentioned, the step size will be 0 0.02. 25. So let me to complete this one. 0 0.75, 0.0107, and then we move one more step. So we try to have several step 1, 2, 3, and 4 and 5. Okay, so these are the step. And initial value will be 0, as you know that the I current initially T, okay, will be 0 as the information given from this problem. Okay, so this is how we have already set out for the step 2. Okay, and then what's the step 3? Step 3, fill in the table. Okay, it's quite straightforward. Just fill in the table. Okay, that copy paste. Step 3. Okay, fill in the table. So how we going to fill in? We have the equation for our step 1 is this one. Okay, and then we need to get the Euler formula. Euler formula, what is Euler formula? Is at here, the step 4. Okay, so basically step 1 and step 3 and step 4 should be together. 1. Okay, so how do we going to fill this one? Okay, so we have a y equal to yi plus 1 equal to yi, and then plus this h. Okay, and then this is given at the top here. So let me change this one to t. So that's why you all need to be know that which one is the dependent, which one is independent variable. Okay, so let us continue this one. Okay, here the y, so we can make this one as our y lah. Y equal to this one, yi. Okay, so here we have 2i, may be slightly confusing, but one of the I is the iteration. Okay, ei. Okay, so almost there. So let me show you if I equal to 1. Okay, since we already have I equal to 0, that we already have fit in. So now let us let the I equal to 1, iteration equal to 1. Okay, not the current equal to 1. And then what are you going to get? Okay, so the y0. So we're going to estimate the y1. Y1 equal to y0 plus a h step side equal to how much? 0 0.025 as we said before. So here also can change. Okay, multiply to our function is equal to this differentiation equation. Okay, so the I here actually is II or the y0. Okay, let me make this a y0. Okay, now you can take your calculator to key this one. Okay, again, try to key using the formula method, the alpha a. You can using alpha a represent this one. Okay, and then if you spit out your calculation. So now very quickly, let me type the answer that I get from my calculator. Of course, I can using the Excel file. That's okay. So let me type them 0938 key, and then next one. Okay, here 0.1016. Okay, this output look like slightly different as what we expect. So you can say that there's an error there. So if we continue, okay, continue from here, I think we will get more closer information. Okay, so number 6, if we key, so this what we get 0.1000, and then if you key in again the 0.1, so you go to repeat after this. Okay, so it look like the steady state time is a 0.015. Okay, because our step size is quite big. If you see it here, it's quite big. Okay, so the estimator is estimator, let me show you. They will estimate 0.05. So let's make at this one, at this point, so it will reach the steady state. Okay, so if we zoom in further, look like, yeah, look like almost okay lah. Okay, but anyway, we do be able to estimate, but that might be some error because we are using the numerical method. Okay, so hopefully this demonstration give you a better understanding about the application, okay, of this Euler method. Repeat for I equal to, or equal to 2 until, in the steps that we want, you iterate 1, after I go to 3 until I go to 6, that you will get this table. Okay, so hopefully you get more insight about the Euler method. So to summarize, it only applicable for the first order directly in our scope. Okay. Okay, thank you. So you can proceed to the next video about another method, the boundary value problem.